Take a look at the Chapter 7 Day 1 worksheet. I believe if you, this is the back side we're going to go with. Front side, you should have just filled in. If you read through the book, you can get those blanks filled in. The biggest thing is the line symmetry and the rotational symmetry. Line symmetry, can you cut a object into two congruent halves where if they folded on top of each other, they would look exactly the same. Rotational symmetry, where we can rotate it less than 360 degrees, and we end up with the same figure. But should have worked your way through that front side. Now the back side is a little different. The first thing I think we need to do here is establish where our coordinate plane runs. So I'm gonna put in a coordinate plane here. And I believe we're running down here. You can kind of tell where it is, but it's a little bit difficult to see. This is an older copy that should probably be redone at some point. I think we're there, and is it here? Sure. Okay. So we want to find the equation of the line of reflection, and we also want to find the coordinate rule. That is, what did they do to this triangle HIP to get to triangle H prime, I prime, P prime, or H1, I1, P1? How did we get from here to here? If you examine the ordered pairs of P, P is at -2, 1, and then P1 is at 3, 1. You can kind of see there. Here's -2, 1, and there's 3, 1. When you look at I, we're at 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So I and I1. This is at 4, 6, and this is at 1, 2, -3 and 6. So if you just look at these 2 points, you go from -2 to 3. The x's, y's stay the same. I's, you go from -3 to 4, and then the y's stay the same. So in terms of what are we doing to the x coordinate and y coordinates in order to get from any one point in this figure to this figure, hopefully it's pretty safe to say you can recognize that the y coordinate will stay the same. So we will end up with y right there. Now if we check h, we're at -1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 2. So h was at -7, 2. h1, I would guess that the y coordinate has to be 2. It is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what we're really kind of focused on at this point is how are we getting from -2 to +3, -3 to +4, -7 to +8. There's definitely a correlation here in terms of how do you get from -2 to 3 and then -3 to 4 and -7 to 8. Some people like to say we change the sign to +2 and then add 1, change the sign, add 1, change the sign, add 1. If we're changing the sign, we're saying we're doing -x plus 1. So that would be the coordinate rule for how we got from this triangle to this triangle. And then the only other thing that we need to do is we have a line of reflection here. So we should figure out where that might be. And it's going to be halfway in between the x coordinates. So if you think about halfway in between -2 and 3, halfway in between -3 and 4, halfway in between -7 and 8. And if you're not sure, you can just average them. -2 plus 3 divided by 2, and I get a half. -3 and 4, add them together, you get 1 divided by 2, you get a half. And the same thing for -7 and 8. So it would be a vertical line where we have right there, which I would call that equation would then be x equals 1/2. So the equation is the line of reflection. What are we reflecting over? And the coordinate rule tells us how do we get from these 3 points to those 3 points. Y coordinates stay the same. We took the opposite of the x coordinate and added 1. We'll work further with this. This day 1 worksheet is kind of a precursor. We'll see more of this when we get into 7.1 and 7.2. Next one, you can, again, the first thing we probably need to do is identify where in the heck the coordinate plane is. I see this right here as my x coordinate. I wanted blue for that, no big deal. And then let's see my other part of my coordinate plane. Let's put it right right here, sure. Again, when we take a look at what the coordinates are to get from P to P1 and then from I to I1 and then from H to H1, we can kind of see what's going on here. I see this as -1, -2, -3, 1, 2, 3. So I've got -3, 3 for this one, 1, 2, 3, 1, 2, 3. I know it's not right on it, but it's pretty darn close. Let's check the I's. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I get -4, 8. I prime. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So hopefully it's pretty easy to see what's going on here. How are we getting from these the coordinate rule? We're taking the x coordinate is staying the same now. Notice we're flipping this direction, and actually the y coordinates are also staying the same. Or not staying the same, but they're just negating. So we're taking and we're changing the sign on the y's. Line of reflection, if we're saying we're going from 3 to -3, how do I cut this in half? Line of reflection is going to be right on the x-axis. That's where my line of reflection is going to be, which would make it a horizontal line of y equals 0. The only thing that might be different if you did this, if you put the coordinate plane in a slightly different place, if you had this one up, it's just going to change your coordinate rule and your line of reflection just a little bit. The idea here is that when we're flipping from up and down, the negation is taking place on the y coordinate. That's the important thing. Third one, we've got a double. First we go from HIP and we flip down to H1, P1, I1, and then we flip from here to here. So there's two things going on. We take these two at a time. So again, the first thing I'm going to do is identify where the heck the coordinate plane is. I think it's a little bit easier to see on this one, if I remember correctly. I think it's pretty clear that we're going here for my x's, and I'm going here for my y-axis. Okay, so now we're working with something we can deal with. So if this is my first step, and then this is my second step, if we look back to what we did on the previous two slides, notice when we flip left to right here, we're going to be dealing with the x coordinate, and then when we flip from up to down, we're dealing with the y coordinate. So let's just focus on the y coordinates here. These are, again, they're pretty close, not exact. I view this as 1, 2, 3, 4, 5, -5, 2 for P. I'm going to call P -5, 2. I'm going to call P1 -1, 2, 3, 4, 5, 1, 2, 3, 4. -5, -4. So if we're talking about for my first flip down, we're going to be dealing with the y-coordinate. We need to negate it, and then we need to figure out, okay, negate 2. How do you get from -2 to -4? Subtract 2 more. Let's check h. This was P1. H was -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. -10. Oh, that was down. That was the H1 one I just counted. -10, -5, and this is 1, 2, 3. H is at -10, 3. So we can check the I as well, but we should be able to see we're negating the y-coordinate and then subtracting 2. Negate it, subtract 2. So the coordinate rule for the y's here are going to be -y and then -2. Change the sign, subtract 2. That's where I get them. So if I'm at I, for the y's for I, 1, 2, 3, 4, 5, 6, 7. Change the sign to -7. Subtract 2 should get me to -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks right on. So my coordinate rule for the y's here are -y minus 2. Now, the other thing we need to do then is now we're going from here to here. We're flipping this direction. So I've already got my P1 up there. P1 was -5, -4. Well, what's P2? 1, 2, 3, 1, 2, 3, 4. So I'm going, this was P1. P2 gets me to 3, -4. So again, we already dealt with the y-coordinate on that first flip. Now when I'm going to deal with the second coordinate, so I can kind of see what's happening here. Change the sign to get +5. How do you get back to 3? Probably a -2. Let's check H. I already had H1 up there. It was -10, -5. My H2, of course, will be at -5. We're on the same horizontal, but I'm at 1, 2, 3, 4, 5, 6, 7, 8. So I'm at 8. So does it make sense that we're going to change the sign to -5 and then subtract 2 to get to 3? Change the sign to 10, subtract 2 to get to 8. So this is going to be -x minus 2. So what we're seeing here, the coordinate rule that will get us from this original HIP triangle to this HIP triangle, we're going to do two things. First, we're going to change the sign on the x and subtract 2, and then we're going to take all of the y's, change the sign, and subtract 2. Let's check the p on both of those. P was -5, 2, -5, 2. If my coordinate rule is right, then P2 should be x-coordinate. Change the sign, gets me to +5, -2 gets me to 3. Y-coordinate, change the sign to -2, -2 gets me to -4. Let's go find out what P2 was. It's right here. 3, -4. We did two things at once. Now, what you're about to learn as well in the very near future, if you haven't already done so, is that when we have a reflection followed by a reflection over two intersecting lines, it's the same as a rotation. This is really a rotation around this point right here. If you follow the P around there, I end up there. Follow the H, I'm going to rotate there. Follow the I, I'm rotating there. And actually we're rotating 90 degrees, or 180 degrees, really, 180 degree rotation through a 90 degree angle. So that is, those will come up again. I think it's in 7.1 or 7.2, but this is a good way to start it. Oh, we didn't do the lines of reflection. Junk. Let's grab a dotted line of reflection here. Oops. And let's throw in where these would be. Halfway in between my +2 and my -4 for my reflection from here to here. What's halfway in between there? I think it's going to be, well, if we're at +2 and then we end up at -4, halfway in between is -1. -1. So my line of reflection, whoops, I didn't make it dotted. That's okay. My line of reflection is halfway in between, so I'm looking at, again, I'm looking at that one and that one, what's halfway in between them. And then I could look at the -5 and the +3. Halfway in between -5 and +3 would be -1. So again, we're averaging the x's and averaging the y's to get those things. So I'm going to say my lines of reflection going down. I'm going to go over. Let's see, that would be y equals -1, and then my line of reflection going over the from the left to the right will be x equals -1. And there we have it. The only other thing on the back of the worksheet has to do with some rotational stuff. The stuff at the bottom, the patty paper thing, will actually, tough to do it with patty paper on the video here, so we'll make sure that we get that covered. For those of you that are missing class, we'll get that. We can show you that as soon as you get back. Type of symmetry, this was on there as well. This has line symmetry. It would be going through there. That's a poorly drawn piece of line symmetry. I should undo it. Line symmetry coming right down there. Very good. Type of symmetry here, again, we're under the assumption that this is an isosceles trapezoid. An isosceles trapezoid will have line symmetry here. No rotational symmetry. I can't turn these less than 90 degrees. This would have line symmetry. We would have one line and we would have a second line. We do need to watch out for the coloring, but I have line symmetry in those two spots. And this would also have point symmetry or rotational symmetry. And it may not be a surprise at the rotational symmetry. This would be the point for it right here. And this would actually just have, I believe it would be twofold point rotational symmetry, because I can't go just a quarter turn because my black shading would end up in the wrong spots. But this would have twofold. So we would say this has line, and this has line, and this has line and rotational. And then when they ask you for what type of fold, it would be twofold for this one. Now this one has line. It has multiple lines, right? I've got basically through all the vertices, and I should be meeting at the same spot. It isn't too bad. I get them all. One more. Okay, there's my line symmetry, and then, not surprising again, the point, for the point that we're rotating. Now this one's going to rotate. We can rotate this one to here, we can rotate it to here, we can rotate it to here, and this is going to have five-fold rotational symmetry. Five-fold. There, you can go. You could rotate it 5 times to get back to itself. Really, that has to do with the number of vertices that you can see here. That's for the number of fold that you have. So, okay. Hopefully that helps you out there. Yeah, we'll deal with this one in class, and that should get you through hopefully everything except those last two. We do these with patty paper. It'll get you through everything except that, and we'll clean that up when you get back to class, or definitely make point of it in class. So hopefully you enjoyed your Chapter 7, Day 1.